Hello my dear students, in this video we will study about resistance and resistivity. So let's start with resistance. So as I told you in the earlier video, what is resistance? Resistance is the hindrance to the flow of current. In other words, we can also say that it is the property of the conductor due to which it opposes the flow of current. From Ohm's law, we can find the value of resistance using the equation V is equals to IR, where V is the potential difference, I is the current, and R is the resistance. Now, when we talk about resistance, what is its SI unit? The SI unit of resistance is ohm, as the concept of resistance was first time introduced by the scientist George Simon Ohm. Now, factors affecting resistance. So, there are mainly four factors that affect resistance. First is length of conductor. Second is area of cross section of the conductor. Third is nature of material of the conductor. And the fourth one is the temperature of the conductor. So, let's discuss how these factors affect the resistance of any conductor. Let's start with the length. So, the resistance of any conductor is directly proportional to the length of the wire. It means the longer the wire, the greater will be the resistance, and the shorter the wire, the smaller will be the resistance. So, resistance is directly proportional to the length of the conductor. Now the second one is area of cross section. So resistance of any conductor is inversely proportional to the area of cross section, or you can also say to the thickness of the conductor. The thicker the wire would be, the lesser will be its resistance, and the thinner the wire would be, the higher will be its resistance. So what is the reason why resistance is inversely proportional to area of cross section? The reason is, if the cross-sectional area of any wire or any conductor is increased, there will be more number of electrons available for the flow. And as the number of free electrons increases by increasing the area of cross-section, the resistance decreases and the conductivity of the conductor increases by the same amount. So, if the area of cross section is supposed doubled, then the resistance of conductor will become half. Now coming to the third factor. The third factor is temperature. The resistance also gets affected by the temperature. Now how does it affect? So there are two main cases. First for conductor and second for semiconductor. The resistance of a conductor increases as the temperature increases. Why does this happen? Because in conductors, when the temperature is increased, there will be more number of collisions among the free electrons, and this large number of collisions basically increase the resistance of the conductor. It does not allow the flow of the current from the conductor. The second is the resistance of semiconductor. Now when we talk about semiconductor, the resistance of semiconductor decreases on increasing the temperature. Now why does it happen? Because in semiconductors, as we increase the temperature, there will be more number of free electrons. The availability of free electrons increases in semiconductors on increasing the temperature, which in turn increases the conductivity and reduces the resistance of the conductor. So in semiconductors like silicon and germanium, the resistance decreases on increasing the temperature, whereas in conductors, the resistance increases on increasing the temperature. Now the fourth factor that affects resistance is nature of material. So every material has its own nature. Because of that, it affects the resistance. Every material has some specific value of resistance present in them. which is fixed. So for different materials, the value of resistance will be different. That's why the resistance of any conductor will also depends upon its temperature, its nature of material. So, if we want to write these factors in terms of an equation, and if we want to derive an equation for resistance, what we can do is we can take the two relations that we have studied yet. Resistance is directly proportional to length and it is inversely proportional to area of cross section. So on combining the first and the second equation, we get R proportional to L upon A, and on removing the proportionality sign, we get R is equals to rho L upon A, where rho is the symbol for the specific resistance of conductor. Now what is this specific resistance? So students, specific resistance is also a resistance of conductor, but it is specific to the particular conductor. It has a fixed value. So if we want to define a specific resistance, then we can say that it is the resistance of a conductor having a unit length and unit cross sectional area. That is, if the length of the conductor is 1 meter and its area of cross section is 1 meter square, then the resistance of that conductor will be equal to the specific resistance. Now when we talk about its unit, so its unit is ohm meter. Now what are the factors that affect specific resistance, or what are the factors on which the specific resistance depends? So mainly there are two factors on which specific resistance of a conductor depends. The first factor is the nature of material. As I said earlier, the specific resistance is characteristic property of each and every material. Each and every material have a fixed amount of resistance in them, and that is the specific resistance of that particular material. Second is temperature. So resistivity or specific resistance has a direct influence with temperature, just like resistance. On increasing the temperature of a conductor, the resistivity also increases. Whereas on increasing the temperature of a semiconductor, the resistivity decreases. The reason being same. But a very important thing which you need to remember about a specific resistance is that the specific resistance does not depend upon the length and the thickness of the conductor. When you increase the length or decrease the length, or when you change the thickness of the conductor, there will be no effect on specific resistance. Although the resistance gets changed, but the specific resistance does not get changed with the change in length and thickness. It only and only depends upon the nature of material and the temperature of the conductor. I hope this is clear to everyone. Now we'll meet in the next video with the next topic.